Hello and welcome to this video. In this video, we're going to be looking at the topic of functions. So what is a function? What do I mean by just a function? Well, a function is anything that takes some kind of input, whether it's algebraic or numerical. It takes that input and it does something to that and it spits it out the other side. So equations are functions. So I could say, for example, I could have a function that I'm going to call f, and the way we write functions, the function's name is f, and it takes x as an input. So whatever we put in the bracket here is the input that we want to put into that function. And so let's say the function of x, so we'd call this f of x. F of x is equal to x plus 2. Okay, so what this function does is it takes the input of x, which we can choose, and it just puts it into this formula, and then it tells you what that value is. So if we said, therefore, if f of x is equal to x plus 2, what is f of 1? Well, that would be, we just replace this x with 1 plus 2, and f of 1 is 3. F of 2 would be 2 plus 2, and and 2 plus 2 is 4. F of 3 would be 5. You get the idea. Now, these functions can be linear like this. They could be quadratic. We could say f of x, or actually let me call this g of x because it's a different function, so it has a different name. Let's say g of x was equal to x squared plus 3x plus 2, for example. If I then had f1, I would just put 1 into here, so this would be 1 plus 3 plus 2. And so f of 1 is going to be 1 plus 3 plus 2, which is 6. Okay, so you get the idea. A function is just some sort of maybe algorithm or formula or something that we do to this number that's going to turn it into a different number. So some examples of some functions that you might recognize that you wouldn't probably think of them as functions are maybe the trigonometric functions. So sine of x, the function is called sine, and x is the input. Cos of x, cos is the function, x is the input. Now we can, if you wanted to, go into more detail about what a sine function does to the thing, what a cos function does to the input, but this is going to be more of a higher or further maths A-level topic, so we don't need to know about that, but just recognizing that these are functions. They take an input, they do something to that input, and then they spit out a new value, means that they are functions. Okay, now with functions we have different things we can do. We can transform functions, we can have inverse functions, or we can have composite functions. So let's first look at what I mean by transforming functions. So transforming functions, we've transformed things before. So we looked at the idea of moving shapes. We had transformations in terms of geometry with translations, enlargements, rotations, and reflections. And we can do all of those things with this use of this function notation. So let's say I wanted to take a function, because as always, I can write any algebraic equation as a graph. I could draw this on a graph. Let's say I wanted to move it 2 spaces to the left. What I would do is I would put in f of x plus 2. And so what this does is I've changed my input. So this means that I'm going to move 2 spaces to the left. Okay, now let's take that thing and let's just prove that this is true. So let's say I had, let's have the f of x that I had before. So before I said f of x was x plus 2. So we'll take a simple function. Now let's say my input has now changed. I'm no longer looking at x. I'm now looking at x plus 2. So my f of x plus 2, where I had originally an x, I now have to put an x plus 2, and that's plus 2. So this means we're plussing 4 to what we had. Okay, so what we start with originally is that we're saying that that if I had f of 1, f of 1 would be equal to 3. But then here, this becomes x plus 4. And so if I put f of 1 plus 2 in, when I transform it, f of 1 becomes 1 plus 4, so it becomes 5. So I've moved 2 spaces along. That's all this is doing. Now, you can think of these as whatever happens inside the bracket, we do the opposite of. So if I had, so anything inside bracket, if so, do the opposite. Okay, let me just write opposite. So in this case, let's say I plotted out a function for x plus 2. Okay, so this is x plus 2, it travels through plus 2 because this is my plus c, it has a gradient of 1. If I wanted to move this 2 spaces, if I've basically said all my x values are now going to add 2 to them, okay, what that means is that all of my y values, or the f of x, so this y becomes f of x now, and this is as a function of x. I know that this has increased. If I were to move this whole line in this direction, then my y values will slowly decrease because I'm going down this way. I don't want them to increase. And so the way, or I know for a fact they're not going to increase, so I have to move them to this direction. So if I want to move my whole thing 2 spaces to the left, I just add 2. If it was 3 spaces to the left, I would add 3. Which makes sense because now if I wanted to maybe move it 2 spaces to the right, I would just have to put f of x minus 2. So let's underline this here. Then if I had f of x minus 2, this would move the whole thing 2 spaces to the right. Okay, and we could prove this again, but I feel like I've overdone it with this proof here, so we'll just say this will be something you can do for yourself. Just put an x minus 2 in here and you'll find that it will be x, so actually we'll have a 1 here, and then you can see which way you'd have to move to make that true. So as a general rule, we say if it's inside the bracket, you perform the opposite. Okay, so we're basically treating all of this f of x stuff, so this term f of x, we're essentially saying it's the same as saying y. Okay, we could also maybe have f of 2x, in which case all of our values would half. So this would half all values. If we had f of x over 2, then we double. So we always do the opposite of what we have inside the bracket. Therefore, it must mean that we have an option that it could be outside the bracket. Let's say I had, I wanted to just say f of x plus 2. Now remember, this f of x is basically treated as y, so all I'm going to do is move all my y values 2 spaces up. Okay, if I had f of x minus 2, they'd move 2 spaces down. If I had 2f of x, I would double all my y values. If I had 3f of x, I would triple them. If I had f of x over 2, I would half them. Okay, so all of these things that are on the outside allow you to perform that to your y-axis. Okay, so everything on the outside, you just perform. Okay, so if it's plus 2, add 2 to all your y values. If it's minus 2, minus 2 to all your y values. Do exactly what it says, but as soon as it goes inside the bracket, you do the opposite of that to all of your x values. Okay, so if it's x plus 2, then you minus 2 from all your x values. If it's x minus 2, you plus 2 to all your x values. If it's 2x, you divide all your x values. And if it's x divided by 2, you double all your x values. So this is how we're going to transform functions. Now let's have a look at what I meant by inverse functions. So inverse functions. So I mentioned earlier that an example of a function was sine of x. But if you remember, when we move a sign to the other side, sine of x, the inverse becomes sine to the minus 1 of x. Now this minus 1 doesn't mean that it's like a laws of indices and this would be x to the minus 1 is equal to 1 over x. That's not what it means. This is not true for this. Okay. For this -1 just means that it is an inverse function. It means that all of your y values become your x values, and all of your x values become your y values. So you're essentially saying, if I had plotted a graph on some axes where I know this was y and this was x, I'm just going to swap these axes around. So now my y values all lie across the x axis, and all my x values lie across my y axis. And what that means is that I'm basically rearranging my formula so that instead of saying y is equal to something, I'm going to say x is equal to something. So let's take an example. Let's say I had a function, I'm going to call it h of x. Hopefully you see the idea. It doesn't matter what I call the function, this is just a name for what the process is going to be. Let's say h of x was just x over 2 minus 4. Okay, and the question asks me to find the inverse function, and they'll usually note it. They won't tell you it's an inverse function, they'll usually just say it's h to the -1 x. This just means it's the inverse function of x. Now the way we're going to do this, treat this hx as a y, so let's just say this is y is equal to x over 2 minus 4. Now we want to rearrange for x, so if we rearrange for x, we're just going to plus the 4 across and then times by 2. So x becomes y plus 4 all times by 2, and so that means that x is 2y plus 8. Now this is clearly not in the form of the inverse function of x, so what we're going to say is let's now switch our variables. So if you remember, this was going to become the y and this was going to become the x, because we need x to be the input in this function. So now I rewrite this properly as saying h to the -1 of x is equal to 2x plus 8. Okay, and this is the inverse function. So in order to find the inverse function, you just write out your function, rearrange it for x, and then just switch your variables back to what they've asked you to say they are in the question. Okay, now finally what they can ask you to do is to look at composite functions. Now composite functions are functions where we will have a function that's an input for another function. So let's show you an example to see what I mean. So let's say f of x is equal to x plus 2, like we've just named, and let's say that g of x is equal to x squared. Okay, these are two different functions that do two very different things. But what if I wanted to make the input, so you can see before we can change this input, we can make it f of x plus 2. What if I make this input g of x? What if I wanted f of g of x? Okay, what would that look like? Well, g of x is now my input, so wherever I have an x, I have to have a g of x. So this just basically means instead of having an x, I'm going to have an x squared plus 2. Okay, so the only difference is wherever I have an x, I'm substituting in whatever the g of x function is, and that's going to give me my composite function. Now this usually isn't written with these brackets. They would usually write it as just fgx, but this means the same thing. Okay, it means that you have a function f that takes g as an argument to it. I could do this the opposite way around. I could say, what if I wanted g of fx, and that means I take my function g, but wherever I see an x, I'm going to put an x plus 2. So this is going to become x plus 2 all squared, and then g of f of x is going to be equal to x squared plus 4x plus 4. Okay? What happens if I wanted to put the same function to be the input of its own function? Okay? This is where it starts to get a little bit mind-boggling, but if I wanted to have f of x, it means that wherever I have an x, I'm going to substitute f of x. Okay, so I'm going to say this is x plus 2, so this was originally x plus 2, so I plus 2. And so f of x is actually x plus 4. This is f of x. What if I wanted g of x? Well, then I can put in g of x wherever I see an x, and g of x is x squared, and that x is squared, so g of x is equal to x to the 4. Now we can be asked to now solve these composite functions. So they might tell you, given that, let's use this one here. Let's use g of f of x is equal to 0, solve for x. And this is just a fancy way of saying solve x squared plus 4x plus 4 is equal to 0, because this whole expression is just the function g of f of x. And so you can just solve this by the regular way that we'd solve quadratics. They could also ask you to state the solution of maybe g of f of 1. And now wherever we see an x in this, we're going to put a 1. So this is going to become 1 plus 4 plus 4, and that's going to become 9. Okay, so this is functions. We've learned what they are. So they're just a name given. So f of x, g of x, h of x, z of x, if you really wanted, you can name it whatever you want, where x is the input. You could even have a of y, where a is the name of the function, y is the input of your function. You can transform functions by changing what you do to f of x or g of x or h of x. You can calculate the inverse function, so work backwards to try and work out what your initial variable was, and you can have composite functions where you put a function inside of another function. Okay, so in this video we're going to look at some functions questions and do some practice in being able to solve these questions. Okay, so they've first given us 2 examples of functions. So we've got f of x is 2 over x squared and g of x is 4x cubed. And first thing they want us to do is find what is f of minus 5. So if we know f of x, remember x is the input of 2 over x squared, where x is now going to be minus 5. That means f of minus 5 is going to be 2 over minus 5 squared. Minus 5 squared is 25. So if we do this, this becomes 2 over 25, and this is our answer. Okay, so let me just write this. F of minus 5 is equal to 2 over 25. Okay, now this one is giving us a composite function here. We have f of g of x, so we first have to find out what is f of g of x, and then we're going to substitute 1 in for all the values of x, because that's going to be our input. So if remember, if we have f of g of x, it means g of x is our input into the f function. So wherever we see an x in f of x, we're going to put the whole g of x function. So this is going to become 2 over 4x cubed all squared. Okay, and now that is going to be 2 over 4 squared, which is 16, over x to the power of 6. Now this 2 over 16 we can kind of simplify, so we can say f of g of x is equal to 1 over 8x to the 6, and then we know x is equal to 1, so we can just substitute that in, and 1 to the power of 6 is going to be 1, and so f of g of x is equal to 1/8. Okay. Now, second question, they've given us another 2 functions. So they've recalled f of x and g of x, and they want us to first find the value of f of 10. So we know f of x is 3x minus 4. So if wherever I have an x, I'm going to put a 10. So f of 10 is 3, 10 minus 4. Now 10 minus 4 is 6. 6 times 3 is 18. So f of 10 is equal to 18. They now want us to find g to the minus 1 of x. Now if you remember, g to the minus 1 of x was the same as the inverse of x, where it actually is the inverse of x. And the way we worked those out is we said, let's just call this g of x y, and y is equal to x over 5 plus 1. Now let's rearrange to make an x equals equation, because we just want to swap the y's and x's, and if we rearrange this, we need to multiply everything by 5, so it becomes 5y is equal to x plus 5, because everything has to be multiplied by 5. And this means that x is equal to 5y minus 5. And therefore, I just change the name of these variables. And this becomes that g to the minus 1 of x is equal to 5x minus 5. And that's your inverse function. Now they want us to show that f of x is equal to 9x minus 48. So this is a composite function again. So where f of x is the function, or is the input of the function of f. So wherever we see an x in this function f of x, we're going to have to put the whole function f of x. So this is going to become 3 times, and the x means 3 times x minus 4, and that whole thing is then minus 4. And so we're basically just working with a bunch of brackets. Okay, so we're going to have to expand this, and we're going to say that if we expand this, we get 3, so this 3 stays on the outside, multiplied by the x, which we're now going to multiply out to be 3x minus 12, minus 4, and this is 3 times 3x minus 16, and then if we do this, if we expand this becomes 9x, and 16 times 3 becomes 48, and so we get our answer. Okay, and now finally we're going to look at a much more difficult example. So we've got the functions f of x is equal to 5x plus 3, and g of x is equal to ax plus b, where a and b are constant values, so they're just numbers. We've been given that g of 3 is equal to 20. Okay, so let's write that over here. So that means that 3 times a plus b is equal to 20. Okay, we're going to save this for later because I feel like we're going to get some simultaneous equations going. So this is our first simultaneous equation. Then secondly, we're going to say the inverse function of f, where x is 33, is equal to g of 1. Okay, so we first have to find what is the inverse function of f in the first place. So y is equal to 5x plus 3. Therefore, x is going to be equal to y minus the 3 divided all by 5. Therefore, f to the minus 1 of x is equal to x minus 3 over 5. Where f to the minus 1 of 33 is going to become 33 minus 3, so 30 divided by 5 gives us 6, which means that g of 1 is equal to 6. And if I put an x equals 1 into this, this becomes a plus b is equal to 6. Okay, so now we've done all of the composite function stuff. We just have to solve these simultaneous equations. We've already got a b in both of these, so we can just minus them to get rid of the b's. This becomes 2a is equal to 14. Therefore, a is equal to 7. And then if I put this back into a plus b equals 6, 7 plus b equals 6, so b must be equal to minus 1. Okay, and therefore a is equal to 7 and b is equal to minus 1. And these are our answers to these questions. So hopefully all of this makes sense. Hopefully composite functions make sense, and solving functions and all of that. And thank you for watching.